Have you ever looked at the sun through a telescope and wondered what those small dark patches are? Well, you must have heard about the term called sunspots. So in this video, what I'll do is I'll try to break down what the sunspots actually are and why do they even appear dark when the sun, as we know, is so hot and bright. To start off, the sun has a magnetic field which is obviously caused due to the moving charges or the plasma inside it. So what actually happens is the plasma kind of flows inside the sun. It gets churned back up due to the enormous heat that is produced in the sun through nuclear fusion. So this of the charges is responsible for the magnetic field of the sun. So sunspots are the region of the sun where the magnetic fields are extremely strong. Now, what causes the magnetic fields in certain parts of the sun to be that strong? So the answer lies in the fact that the sun has a differential rotation. What does differential rotation mean? Well, the equator of the sun actually rotates much faster as compared to the poles. So due to the differential rotation of the sun, the magnetic fields kind of gets tangled up and bunched up at certain locations. Thereby, those locations essentially have a much stronger magnetic field as compared to the other parts of the sun. Now, just to give you a quick reference of how strong the magnetic field actually gets. So the regions where we see sunspots actually have magnetic fields of about 1,000 to 4,000 Gauss. Now, to give you a quick comparison of what that is, average magnetic fields of the Earth's surface is about 0.5 Gauss, and the global average magnetic field of the sun is about 1 Gauss. So now compare that with 1,000 Gauss at certain places. So essentially those sunspots have magnetic field strengths about 1,000 times stronger than the other part of the sun. Now, what happens due to the strong, intense magnetic fields at certain spots? So what they do is it inhibits the flow of the plasma from the surrounding photosphere into those locations. Now, as a result, those locations are cooler as compared to the surrounding photosphere. By cooler, I mean they are about 4,000 Kelvin or about 3,700 degrees Celsius as compared to the 5,800 Kelvin or 5,500 degrees Celsius of the adjacent photosphere. So when I say that sunspots are dark, they are actually dark as compared to the adjacent surrounding photosphere. Now, if I could cut out a small portion of a sunspot and place it on the sky, it would actually appear to be as bright as any other night sky celestial object like the moon. The sunspots are actually not dark. They appear dark because they are slightly cooler as compared to the adjacent surface. Sunspots have a lighter outer section called the penumbra and a darker central section called the umbra. These sunspots are actually very massive, almost like a planet-sized. So the umbra of a sunspot can be about 12,000 miles or 20,000 kilometers wide. Now compare that to the diameter of the Earth, which is 12.5 to 13,000 kilometers. So they are actually so huge. Did you know that these sunspots can actually vary from a day to few weeks or even up to a month? The sunspots are also used to keep a track of the solar cycle. The magnetic fields of the sun actually flips after every 11 years or so. So when that happens, the sun goes through a cycle of increased solar activities. So the sunspots can actually be used to give us an estimate of the solar cycle. So during the beginning of a solar cycle, as we call it a solar minimum, we have the least number of sunspots. At the middle of the cycle, which is called the solar maximum, we have the maximum amount of sunspots. And at the end of the cycle, again, we come back to the solar minimum. So essentially, sunspots also help us in understanding the solar cycle or getting an estimate of where actually we are in that solar cycle. So I hope you learned something interesting in this video. If you did, please consider subscribing the channel. That way, it'll also give me a little bit of motivation to make better videos. I really hope you enjoyed this one. Catch you up in the next one.